So hi everybody, I'm Christophe Pettus. I'm the CEO and lead consultant of PostgreSQL Experts. We're a San Francisco PostgreSQL consultancy. I'm also a member of the Postgres community infrastructure team. And that's me, and here we go. Let's talk about Postgres 13. Postgres 13 is brand new. It's right now in beta. Beta 1 was released on May 21, so it's available now. Including both for source downloads and through the packaging system, so you can download it and test it, please. We need the whole community involved. Don't just rely on the core developers to pound on it. We especially need testing on large data sets, and if you use partitioning, there are a lot of partitioning improvements and fixes in this version, so we really encourage everyone who uses partition to set it up on a test instance and go wild on it. So there's a bunch of wonderful new things in it. Let's go. First, just some background. Also, this is just an overview. Consult the release notes because there's lots of stuff that I won't be able to talk about in one session, but I'm just hitting what I think are the highlights. So there we go. Just a reminder that PostgreSQL's release numbering changed. This will probably be the last time I have to put up this slide. Pre-version 10 versioning, we used a three-part version number, so 942. The major version was 9.4 and the minor version was 2 in this numbering scheme. As of version 10, we got rid of that third number, and so in 10.3, the major version is 10 and the minor version is 3. So a jump from 11.2 to 11.3 is a minor version upgrade, not a major version upgrade. But going from 10 to 11 to 12 to 13, those are major version upgrades. PostgreSQL's major releases are roughly time-based. It works out to about one a year. That's the official release roadmap. Major releases aren't held for particular features. There's no, well, version 10 is this headline feature and something like that. It's once enough stuff has accumulated and the release calendar comes up, it's released as a major version. So there's no guarantee of a headline feature for a particular major release. So often releases tend to have a bunch of smaller, really cool stuff rather than, streaming replication or logical replication or something like that. Minor releases tend to happen when enough fixes or a critical patch, like a security patch, are ready to go. Just a reminder, install minor releases promptly. It's always depressing to walk into an installation and see a 5-year-old minor version running when it's really just a restart to install a minor version. Okay, this is my personal idiosyncratic breakdown of the new features. Probably the biggest set of changes in version 13 versus the earlier versions are on partitioning. The features here seem minor, but in real life, I think they're going to be quite significant. The first one I want to talk about is partition-wise join. If you join between two partition tables, in older versions of Postgres, using native partitioning, it would do something pretty horrible. It would not, rather than, even if you were using the partition key to do the join, it would do this in a kind of a not very smart way. It would look through each table individually and calculate this really bad plan. In version 11 and 12, there were improvements to this. This happens when you are joining two partition tables against each other and with an equijoin, that is to say the equalities operator, and you're using the partition keys as part of the join. You can imagine like an order table and an order items table where you're using the order, where it's being partitioned by, say, order number or date. There are significant improvements in the performance of this. Now, one gotcha though is to enable these, you have to turn it on. There's a configuration parameter in PostgreSQL.conf that enable partition-wise join. You have to actually turn this on. If you do this kind of joins, at least on an experimental basis, turn it on. It does increase plan time because it has to go and study to make sure that this kind of join will really work. But if you do these kinds of joins where you join two large tables against each other using the partition key, two partition tables using the partition key, this can be a significant improvement in performance. So try it with this parameter. Partitions and logical replication. Now, one of the restrictions on built-in logical replication in Postgres has always been you could only replicate from a real table to a real table. And unfortunately, the root table in a partition set doesn't count as a real table in this case. So, for example, you couldn't replicate into a partition table and have the partitioning mechanism just sort out which partition thing should go into. If you had two partition table on one side and a partition table on the other, you had to individually set up replication between the partitions, which was horrible. And version 13 removes this restriction. Yay, please everybody applaud, because this is a big deal. You can replicate from one root table to another. The advantage here, or you can replicate from a regular table to the root of a partition table. They have to have the same name in built-in logical replication, but they don't have to be the same kind of thing. This makes it much, much easier to move from an unpartitioned table to a partitioned one, because you can set up the logical replica, partition the table, and then use logical replication to create the new partition set. This is very, very nice if you're moving from an unpartitioned table to a partitioned table. And we get triggers now on partition tables. You can create a before row level trigger on the root table, and that will fire on any appropriate operation, an insert, delete, or an update. And it'll fire on everything regardless of which partition it goes into. Previously, you had to create the trigger on each individual partition, and that was horrible. There is one gotcha, which is you can't change which partition the row is going to go into. It's already decided at this point which partition the row is going to go into. So you can't use this to either move an existing row on an update from one partition to another, or on an insert, excuse me, to change which partition it'll go into. You can modify the partition keys as long as you don't change which partition it's going to go into. If you try to do that, you'll get a constraint violation. Okay, the next kind of bag of features I'd like to talk about are performance related. Btree indexes with duplicate keys. So suppose you create a Btree index and there are lots and lots of rows, but only a few key values in the Btree. Traditionally, this has been very, very space inefficient. Btrees in this form burned up a lot of space, and it's one of the reasons we have Btree Indexes actually is because of this. Some really heroic work was done by Peter Geoghegan to compress these, and it saves both time and both disk space and lookup time considerably. So if you have an index which has relatively few key entries compared to the number of rows, this will be a big savings. One gotcha is that if you just do an in-place upgrade using PG upgrade or something like that, you won't get this advantage. So you'll have to either do a re-index on the existing index or create a new index to take advantage of it. So, hash aggregates and grouping. Frequently, Postgres will do a hash aggregate of some sort when it's executing a plan. This builds a hash table, and the hash table can only get up to a certain size. It can only get up to workmem in size. If it exceeds workmem, or specifically when it's planning the query, and Postgres thinks it's going to take more than workmem, it won't do a hash aggregate or a grouping set, and this can frequently be inefficient because this would be a really good query, but it insists that it fit into memory. As of version 13, these can spill to disk. Now you may say, wait, how does moving stuff onto disk improve performance? Excuse me, because obviously doing things on disk is significantly slower. There are two advantages. One is maybe it's a relatively small amount of disk space and it's not going to burn that much, and often you're near the edge of where the planner thinks it will exceed workmem, and the planner would, even for a query where this would work just fine, skips using these very efficient plans because it thinks it will exceed workmem. This performance optimization will allow it to continue to use these potentially more efficient planner nodes, even in those cases. There are improvements to Toast. Toast is how Postgres stores large objects that won't fit in a single row. It stores them in this auxiliary table called the Toast table. The old horrible way is, before version, I believe, 11, is it would retrieve the entire Toast item no matter what you were going to do with it. So even if you only needed the first byte, it would grab the entire gigantic Toast item, load it into memory, decompress it, and then get you the one byte and throw the rest away. That wasn't so great. As of version 11 and 12, it would retrieve the whole thing, but it would only decompress as much as required, which is better, but come on. Let's say it's a 12 gigabyte, it's a 1 gigabyte thing and you only need the first 100 bytes. That's pretty horrible. Now it only decompresses and retrieves as much as required. So yay. So this is a significant improvement if you're doing prefix retrieval on a Toast item. You only need the first 100 bytes or something like that. There is one gotcha, which is there's this common procedure that's being distributed out there. I've used it, everybody's used it, that checks for Toast for Toast corruption. And the way it does that is it grabs the Toast item and does a substring on it to get the first 100 bytes. Well, now that won't work because it isn't even going to look at the other parts of the Toast table, and there could be lurking corruption in there. So now you have to examine the whole thing. So you'll have to fix all of your Toast corruption scripts. Fortunately, Toast corruption is pretty rare. Okay, there's a bunch of new features involving database administration. Pretty cool. There is a new tool that ships with Postgres called PG Verify Backup. This works because PG Base Backup in version 13 writes a backup manifest into the base backup itself. This includes a hash of the data in it, so PG Verify Backup can check it to make sure it's all there and intact, which is nice if you're using PG Base Backup as an actual backup tool. It's also useful just if you're using PG Base Backup to say set up a new secondary, you can run PG Verify Backup to make sure you got everything. So Postgres extensions had previously this characteristic that really you had to be either the database owner or a super user to create them. On hosted situations, you're often neither the database owner or the super user, and so you couldn't create extensions, or you could only create the extensions that someone let you. As of version 13, extensions can be marked as trusted, and if the user has the right permissions, even if they're not a super user or a database owner, they can create them in the database. This is potentially extensions are marked as trusted in the extension control file, so whoever authored the extension and packaged up the extension marks it as trusted. So of course, if you're installing it in your system, make sure that you really do trust it. There's no central authority that's marking things as trusted or not. But this is potentially very useful for hosted environments, assuming the hosted environments pick it up, so that non-core extensions can be marked as able to be created easily in the environment. And if you have an environment where non-super users are creating databases and want to install extensions, this could be very useful. Okay, and improvements to vacuum, everybody's least favorite operation in Postgres. Yes, we finally get parallel vacuum. Okay, it's not everything we could hope for, but it's a lot. Specifically now, vacuum can work on multiple indexes at the same time. So if you have 20 indexes, you can fork off a number of workers, and they can work on more than just one index at the same time. You specify the number of jobs in the vacuum command. There's a parallel option now on vacuum where you can specify the number of workers. If you don't specify a number of workers, there's a fairly elaborate algorithm for how many workers you get if you just say vacuum parallel. If you don't include the parallel keyword, it will not do parallel vacuum. It'll do old style sequential vacuum. Right now, auto vacuum and vacuum full do not support this. This is it's only on the it's only on a manual vacuum command and a regular vacuum, not a vacuum full. Vacuum analyze will support it though. Okay, and if just to talk about that a little bit more. Oops, can't do it. There we go. If you've ever experienced it, index vacuuming can take a long time over multiple cycles. So having parallel vacuum here, vacuuming a large table, can be extremely useful. There are a bunch of enhancements to monitoring. Specifically, we have a bunch of we have some new and improved system views. There is now a PGStat progress base backup, so you can tell from the system that is being backed up by PG base backup how far it's gotten. There's also a there's also monitoring on the base backup command itself to even if you're not running in verbose mode, to show you how far you've gotten, which is nice. We have another view to monitor the progress of analyze operations if you're doing an analyze on very large tables and are curious how that goes. And PGStat replication has been enhanced. This feature requires some explanation on how logical replication works in Postgres. So here we go. Hang on to your hats, we're going in. The logical replication is built around a framework, which people probably know, called logical decoding. Logical decoding reads the wall stream and then sorts everything out into individual transactions, so it can then decode these transactions in order. This decoding mechanism needs to keep around the transaction information, so it's stored in a separate data structure in memory. Now, of course, a transaction in Postgres can be unbounded in size. There is no upper limit to how much data a transaction can process. So at some point, it needs to spill it to disk, or potentially could need to spill it to disk. Let's say you're doing a copy operation and updating 12 gigabytes worth of data. That data has to can't all be kept in memory by the logical decoding framework, so it starts spilling it to disk. Now, previously, it had this hardwired mechanism for when it starts to spill to disk, but you could run out of memory that way pretty easily if you were doing things like if you were doing sub-transactions or save points or other kinds of exotic transaction control features. Now it actually sets a memory limit, so you won't run out. You can keep it from running out of memory. There's a new system parameter, logical decoding work mem, which puts the upper limit on how much of this stuff it's going to keep in memory before it starts spilling to disk. There's also potential efficiency gains here because previously it may have started to spill to disk too early. The PGStat replication view has been updated to keep track of how often you're spilling to disk and how much stuff got spilled to disk. So you can monitor that and say, maybe I can bump up this parameter a little more and keep things from spilling to disk. This is very handy if you're tuning logical replication, especially if logical replication is processing big transactions. So there you are. It's a niche feature, but for people who need it, it's very, very important. Now we can keep track of wall usage. Lots of things produce write-ahead log. Queries do, of course, inserts and updates and deletes and stuff. Vacuum creates wall, and now these all can track how much wall each of these creates, so you can see where all this wall is coming from. So explain output, auto explain, auto vacuum, and PGStat statements all track how much write-ahead log they're generating. And it's useful for tracking down where does all that wall come from, kind of thing, because frequently say, where did this, suddenly I'm spewing all this write-ahead log information. What happened there? It's probably auto vacuum, but this way you can track it down. Okay, now who has ever choked their system by logging too many queries? Me, I have. It's very easy to do. You set logmin's duration statement to 0, and suddenly your system falls over because you've suddenly amplified all your writes. Very, very, very bad. Very surprising. This can be a problem if you have lots and lots and lots of very, very small queries, because that can be a big performance hit, but it's hard to capture. PGStat statements helps, but PGStat statements tries to normalize the queries into a single type, and so you may not see the parameters, and that can make diagnosing these things kind of hard. So now we can statistically sample a subset of queries. What you do is you set min duration sample to a time value like 10 milliseconds, and log statement sample rate to a number between 0 and 1, like 0.5, or let's be really aggressive and say 0.01. And that means it will try to sample 1/100th of the queries shorter than that, longer than that amount of time. So for example, you could set it to 0 and say anything over that time, give me 1/100th of those. So And of course, you need to set it to less than log min duration statement, because log min duration statement means log everything over that time. And if you set duration sample, you'll just get everything. But this can be very handy. For example, you might set min duration sample to 0, sample rate to 0.01, and log min duration statement to 250 milliseconds. And what you'll get is every statement over 250 milliseconds and 1/100th of the ones over 0 of all the others. And that can be very handy for tracking down what's going on with very high rate but short queries. Okay, and my favorite of the new features, Jenrandom UUID. It generates a version 4 UUID. That's all it does. But it's in core now. You don't have to install an extension. You don't have to install OSSP UUID or PG crypto. And thus you don't need all the dependencies that come with those, which can be a pain in the neck on some systems. And maybe I'm just easily amused. And there is lots of other stuff. The release notes go on and on and on, so check them out. There's lots and lots of performance enhancements in this that apply to all sorts of workloads, not just partition tables, not just data warehouses, but a lot of your applications will run faster. Okay, and with that, let's open it up for questions.
Okay, I don't have any questions in the chat queue, so if you have questions, you can just turn on your mic and question away. Oh, wait, Quinn says he has questions. Quinn, you can unmute yourself and start asking.
Hey everybody.
Quinn.
Oh, I think I should take off my headset because the mic sucks. Sorry about that. Can you hear me okay?
Mm-hmm.
Great. So thanks for this presentation. It was lucid and useful and makes me excited about upgrading as usual. So it's cool. I wanted to ask about the toast prefix optimization.
Mm-hmm.
I probably should know the answer to this, but will that help with JSON B values? I don't actually know how those are represented on disk.
They're handled by the standard toast mechanism, but they're binary encoded. I don't remember if the default storage class compresses them or not. I believe it will over a certain size. I'm not sure how much. I guess given that there's all kinds of strings and stuff in them, the compression, the deflate will get some mileage on them. Sadly, it probably won't help much. As much as I'd love to say it'll be this fabulous win, just because of the structure of them, it will probably have to consult a fair amount of them. So I don't think so. For example, even if you were like pulling out what happened to be the first key in the first object of it, it may have to decompress the entire thing, or at least a significant chunk of it. So the real answer is I don't know, but my guess is probably the heavens will not open to this for JSON B stuff. And probably it's even worse for JSON no B, because it'll have to find like matching brackets and stuff like that can cause it to need to deflate the entire thing.
Yeah, okay, cool, makes sense. The other question I had was, does the parallel vacuum feature work with a vacuum freeze?
Well, yes and no. It does work if it's doing a freeze, but a freeze operation isn't any different for indexes than it is than a regular vacuum. On the index. And right now the heap part's not parallelized. That's obviously the next big watershed is we break up the table and run in multiple workers on the heap, but that's not implemented yet.
Cool, thank you.
Yeah, but if it happened to be doing a freeze at the same time as a regular vacuum, you crossed over the threshold whose name I can never remember, and it's doing a vacuum freeze in addition to a regular vacuum, then it will parallelize the index parts.
Any more questions, Quinn?
Yeah, I miscounted. I don't have 3, just the 2.
Oh, okay, great. So Thomas Flatley has a question. Thomas, do you want to ask, or do you want us to read your questions?
Don't be
Okay. So let's see. So no mic. Okay. What is the status of zheap or other storage engines?
Well, we now get to see there's a access method line in the explain plan. Yeah, don't everybody gasp at once about how advanced this has become. Work is continuing is the answer. I would say it's probably going to be at least version 14 before we see anything. I would suspect it's going to be more like version 15. There's a lot of work going on there. Now, the good news is that work is in fact going on, but I think it'll be, but there's nothing is going to be happening in version 13 as far as new storage engines being released in core. You can right now download and run other storage engines if you're feeling bold, but they're not shipped as part of core. But you can see in the explain plan, it'll tell you what storage engine you're using. So yay for that, I guess.
Yeah, it's something. Also, was there something that didn't make it into version 13 that you wanted to see?
Nothing immediately pops to mind. I would love to see like zheap make it in, but that's probably going to be version 15. You know, but there's a lot of stuff. There is a lot of work going on. You know, everyone is working very diligently on basically no vacuum heaps. That's kind of the next huge frontier in Postgres. A lot of work went into version 11 and 12 to create a clean API for the heap access method. Basically, what is internally called the heap access method, which everybody else in the entire universe calls pluggable storage for Postgres. But it's not quite there yet. But it'll happen. You know, the current heap structure has served us long and well, but it's been around since Postgres no QL days. So
okay. Which storage engines can be added as extension?
Super question that I may have to send out a note to the list afterwards because I'm not sure of the status of them. I believe you can download and run zheap now. So check that one out. Other than that, there are column restore engines that can be there's the Citus column restore engine, and that's run as an extension. I believe that actually plugs into Postgres as a foreign data wrapper though, not as an access method.
zstore?
Maybe I'm confusing zstore and zheap. Entirely possible.
Okay, well, that was easy. More questions? Anybody?
Hey, this is Gabrielle. I don't have a question. I just wanted to express solidarity with you for also overrunning my file system with long messages. Oops.
It's really bad on RDS because RDS's logging goes the same volume as the database, and you're doing inserts of like tiny little rows, and suddenly you've like done times 12 write amplification by turning on your logging high, and everything falls over, and it's all very embarrassing.
Great. Okay. Checking the chat window. I don't see any new questions. So I guess you've given everybody everything they need to know.
Or it was completely unintelligible, one way or the other. I'm content either way.
Yeah, I thought it was great, and I like doing the cross group meeting thing too. I think that's neat.
Well, it's a chance. It's an easy way for us all to get to know each other, or at least each other's little icons, and build a little more community. Oh wait, Jignesh, can I get the question for RDS again? Jignesh, can you?
Because it's. I could go behind a rock with no human being in 12 miles and whisper, I have a problem with RDS, and then suddenly an RDS engineer would appear next to me. I love you guys. RDS is particularly sensitive to this write amplification issue of turning up logging because the logs go to the same volume as the database itself, as opposed to a separate volume. So it's not really a question, it's just an observation. And RDS is hardly alone in having that configuration, of course. That's a very common configuration for databases. So no slander on RDS, it's just because we work a lot on RDS, we just happen to notice it.
Okay. Anybody else? Comments, questions? Okay, well, that was fun. It was nice to see some new faces. Oh, wait. Oh, yeah. We have a comment, applause.